Hello, this is Jules from VR Tracker. Today I want to show you a quick experiment I've done over the weekend. The goal was to do something like the company 3D Rudder did. I don't know if you've heard about it, there's been a lot on them at the CES, and I thought, well, the tech is very simple and we could easily do that with one of our tracker. Just to show you what 3D Rudder does, it is a platform that you can put your feet on to be able to move in virtual reality. So the goal is to be able to move around while you are seated and do that easily. So they sell this technology. It is compatible with a PC headset like the Vive or Oculus. It doesn't work with a mobile headset though. You can check maybe a bit their video to understand. So you see the platform is under their feet, and that allows you to move in the game. So I thought this is quite simple, and well, we could use one of our tracker and use a board such as this one, put the tracker on and test if it would work. So let me get you through the Unity script I've done for that. So first I've created a new scene that is called 3D Rudder Do It Yourself. I've just added a few elements to the scene so that you could have some stuff to see. And I've created, so let's just go to intro assignation. You can see in the build settings I have the intro assignation and the 3D Rudder Do It Yourself as a second scene. In the VR tracker I've changed the online scene to 3D Rudder Do It Yourself. And I've changed the player prefab. I created a new player prefab which is called VR Tracker Player 3D Rudder. Let's just have a look at that prefab. So actually you can see it is based on a network prefab, so you can use it as in a multiplayer environment. And I have just one VR tracker headset. That and that I could actually remove. This is the player body. So there is one VR tracker headset with a script. Okay, so the enable and load is only for the camera, and this is the script that I've created for the 3D Rudder-like movement. And then we have a tag containing the VR tracker tag script with the orientation enabled, the smoothing enabled too. So that tag doesn't actually hold any game objects, so you won't see it in the game. But what we want to do is to be able to grab its orientation and transform it into a position. So that's why on the VR tracker headset, which holds the camera that we want to move with our feet, I have created a tag, a script called VR Tracker Tag Orientation to Position. So the first thing I need to do is to assign the game object that contains the VR Tracker tag, and then I have a few offsets that I can use for the movement. Let's simply go to that script. You can see it is pretty easy. What we do is simply in the update we get the orientation from the tracker. And now here we check that here and here what we do is that with the orientation we check that if it's over 180 degrees we remove 360 degrees, because if the orientation goes this way it's gonna go from 0 to 1, 2, 3, 4, 5 degrees, but if it goes this way it goes to 359, 358 degrees, and this is not what I want because I'm going to use that value in degrees to convert it to a position. So I want a -1, -2, -3, which is the reason for that condition, and the reason for those conditions too. So what I do first is that I'm gonna keep the orientation along the y-axis, so the movement like that. But what I want to do is that if the boards move just a bit like that with my foot, it's not going to just the camera is not just going to do that, but it's going to continue rotating until I get my foot back in place. So that's why I have I do the orientation.y plus equal the tag rotation time the time delta time the rotation offset. So the rotation offset and the position offset, they are for the rotation speed or position speed actually. So this is what I do here. This is for the orientation. Then I do a check. So here and here I check that the orientation is not over the stability range, which is set currently to 5 degrees, which means that, for example, if my foot are pretty stable, I don't want the position to change. I want to be stable. And if the orientation is over 5 degrees, I start calculating the new position. So this is what we do here. Math.abs orientation inferior at stability range. I set the orientation to 0, and the same thing happens there. So now the new thing we do is that, okay, so first we apply the calculated orientation to the rotation of this object, which holds the camera, so that's gonna move along Y. Then I create a new vector, an orientation vector, based on the tag rotation, and I only use the Z and the X axis. So I check to remove 360 degrees, I check that I am in the stability range, and there I calculate the translation from the rotation. So the translation is equal to the orientation time the position offset time the time delta, the delta time. This is to have a fixed position update, fixed to the time in second, not to the frame rate. And then I apply a translate to my object, and that's it. So let's have a try at this. I'm gonna turn the tag on. Okay, so I'll just set the orientation to 0 by pressing on the red button. Then I'll put my foot there, and as you can see, I can move backward, forward, on the side, on the left, on the right, and I can also turn around by moving my finger like so. My feet. As you can see, this works pretty well. This does what we would expect, I think, from a 3D rudder, even though I've never tested this device. The nice part with using a VR tracker tag is that it makes it wireless and compatible with any headset, even mobile headset. It took me exactly 1 hour to create this application based on our examples that you can find on the Git, and you can also find this example on the Git in the example scenes. So don't hesitate to try it yourself. In my opinion, this way of moving in virtual reality is really not great. It doesn't feel natural at all, and I think it would create a lot of motion sickness also. So I wouldn't recommend it, but it was cool to do this test and to also be able to give you my feedback on this kind of devices. So I hope you like this test, and well, have all a great day. Bye.